Hello from IP SoC 18 in France. I have the pleasure to be with Martyn Bronziet, who is a field application manager at Synopsys, the company you know very well, of course. As we are in Europe, I think he will focus on the automotive market, and especially an autonomous vehicle. And I think he will address many challenges, of course, including safety. So, what's new at Synopsys in this area?
Thank you, Gabrielle. Yeah, so we're in the presentation that we gave earlier today, we provided an overview of the autonomous vehicle levels, the different levels of automation, and where we're heading, where the market's heading. We looked at some of the challenges that have to be overcome. Things like when a vehicle approaches a complex junction, the decisions that have to be made. When there's a pedestrian trying to, when a human sees a pedestrian who's driving a car, you have some idea of how they're going to react based on how they're walking if they're approaching a crossing. So these are some of the things we have to negotiate as autonomously, and we also have to allow for tracking of multiple moving objects to try and understand the overall context of how vehicles are going to move. If we're driving on a motorway, we're in the middle lane, we have a vehicle on either side of us. Is it safe to start an overtaking manoeuvre? So we look at these challenges. We look at the way the processing that we can do using neural networks, convolutional neural networks, which are kind of pre-trained in order to make decisions, such as when beginning an overtaking manoeuvre, changing lanes, even coming off a motorway, moving off a slip road, and approaching junctions. So these are all decisions that have to be made real time by a processing engine inside a vehicle. So we've had this very complex processing going on. But then the nature of a vehicle is that it's a very noisy environment, so you have a lot of noise, so you have to make sure that your systems have the right features to be able to provide safety robustness. So we have to be able to, if there's an error, a random error that's introduced, we have to make sure we can recover from that error. So it would be very bad if the brakes were to suddenly come on a vehicle when we're driving very fast, and it could have very severe consequences. So we have to be able to detect these decisions, these occurrences, and make decisions to still allow a system to function. So we look at the Synopsys solutions. We have the processing engine to carry out these complex neural network functions, but also we have the systems in place to allow us to make sure that's done robustly. So things like dual core lockstep processing, ECC protection, and self-checking, logic self-test, memory testing, all these things that are run real time to make sure that the system is functioning correctly and able to recover from any errors that occur. So that's really the thrust of the talk today.
So I have just a question. You mainly speak about recovery. So I think your main vehicle for providing safety is fast recovery and efficient recovery, or is it more a processing feature? So you spoke about neural network. You have recovery process, you mentioned them, but the fast processing, the neural processing is done on what? On your processor, on your ARC processor, or what?
Yeah, so the neural network itself is right. We have a dedicated solution which consists of a processing engine, general purpose processor, which is also capable of vector DSP operations, but then we have that tightly coupled to a dedicated convolutional neural network engine. And all these processing solutions have built-in safety mechanisms. But we also, in order to have safety robustness, the development process also has to take this into account. So we have features that we deploy on the hardware, but we also have to make sure that our design process and our verification takes into account the safety aspect as well.
Okay, so it's a real challenge. We all want to be safe in your autonomous vehicle. Okay, so thank you very much.
Thank you.